Welcome, guys. So this is our Google Sydney meetup. Welcome, everyone. And today is a special day for us, I guess. Two of our people from Nepali community is going to give some talks and make us proud, I guess. Let me introduce you one of the first speaker, which is Prasiddha Bista. Thanks, guys, and let's hear him.
Should I start? Oh. Can everyone hear me? Yeah. Cool. All right. Hello, everyone. Thank you so much for coming to this talk on using Google Cloud Functions to build a serverless Slack bot for fun and no profit. Too quick. My name is Prasiddha Bista, Pras for short, and I'm a software engineer at Stacks. You can scan the QR code on the page today to follow along with the slides. I wanted to start off by asking a quick question to everyone here today, which is how many of us have used one or more cloud providers? So Google and Amazon or Amazon and Google? Quite a few. I'm also amongst those. So on my day-to-day job, I use Amazon as my primary, that is where I develop and work on. But I built this application in Google Cloud, which has given me this opportunity to learn more about Google Cloud technologies. So I'd really appreciate if you could provide me with feedback at the end of the presentation. Hopefully everyone has scanned the QR code if you wanted to follow along with the slides. Okay. Stacks is an AWS cloud management platform, which enables organizations to quickly build and renovate on the cloud, whilst taking care of necessities like security, identity and access management, cost and compliance, risk management, and reporting. Stacks has built a total cost of ownership calculator, which anyone can play around with by visiting stacks.io/TCO-calculator, which will give you a quick representation in terms of the cost difference in having to build a solution like Stacks versus buying it outright. In terms of the agenda for today, we'll talk about the serverless Slack bot. We'll see how we can test the application locally. We'll see how we can deploy the application to Google Cloud using Terraform. We'll look into continuous integration and continuous delivery using Github Actions, which will then be followed by a quick demo on how the Slack bot works. We'll then look into how we can use Google-provided tools in terms of logging, monitoring, and tracing to monitor the health of our application, which will then be followed by a quick slide on key takeaways for this talk. And we'll finally end this talk with a note on Explorer's Slack community. In terms of the architecture itself is really simple. We subscribe to a few events in Slack. Whenever those events occur, Slack will then forward those events to our Google Cloud function. The function will then process the event accordingly and respond to Slack. For instance, if a new user has joined the Slack workspace, the bot will then welcome the new Slack user. And if a user has posted a message in the Slack channel, the bot will then check the text for any matches for emojis, and if there are any matches, it will then react to the Slack post with those emojis. But we'll see that in a demo example in a bit. In terms of the technologies used, Slack for event subscriptions, Google Cloud Platform to deploy the application, Terraform as the infrastructure as code tool to deploy the application to Google Cloud, TypeScript as the programming language of choice, CI/CD with GitHub Actions, and finally Sonar Cloud for code quality and security analysis tool. You can visit these URLs at the bottom to look at the application code and also the CI/CD code that we've implemented with this application. Google Cloud Functions is a serverless pay-as-you-go compute environment, which lets you build applications without having to worry about the underlying service. It is stateless, it's ephemeral, and it scales automatically on Google Cloud's infrastructure. There are two types of Google Cloud Functions, mainly HTTP functions, which you invoke using a HTTP or a HTTPS URL, or an event-driven function, which is triggered based on an event emitted in the cloud. For example, when an object in a cloud storage bucket is deleted, that can be a trigger for your cloud function. There are many use cases for cloud functions. It can be used to build web applications as backend as a service. It can be used to process large amounts of data as batch processing. It can be used to build APIs and automation. And it's heavily used in event-driven workflows. There are also two generations of cloud functions, Generation 1 and Generation 2, and we'll talk about it in a bit. In terms of running cloud functions locally to test your application, there are two components of cloud functions that are open source, namely Cloud Native Build Packs, which allows you to run a Docker container locally, which then mimics the Cloud Function environment, which you then invoke to test your application. And the other one is Functions Framework, which we're using in this case, which allows you to run a local HTTP server, which mimics the Cloud Function environment, which you then invoke to test your application. And even though you're testing this application locally, these logs are also available in Google Cloud Console. Now that we've seen how we can test the application locally, let's see how we can deploy the application to Google Cloud and test it there. For this, we're using Terraform, and the way this works is Terraform first authenticates to Google Cloud using your application default credentials. Terraform, when we run Terraform init, it initializes Terraform's backend. So it stores its state file in the cloud storage, which is the backend for Terraform in this scenario. This is also where it stores the state file, and the state file is what contains the configuration changes that Terraform makes in your cloud provider. Then it also initializes all the providers and plugins that you might have in your Terraform project. Then you can run Terraform plan, which gives you a quick representation of the changes that Terraform is going to apply to Google Cloud. And when we're happy with the plan, we can then run Terraform apply, which actually goes off and applies those changes to Google Cloud. And then once we're done testing, and if we want to delete all the resources, we can run a simple Terraform destroy command, which deletes all the resources that it's deployed or created in Google Cloud. This is a quick example of having run Terraform apply command, which shows that it took about 1.5 minutes to deploy the Cloud Function and its resources, where it's added 3 resources, changed 1, and it destroyed 3. Now that we've deployed the Cloud Function using Terraform, there are a few steps that happens behind the scenes. It actually triggers a build process in Cloud Build Service, and that build process in Cloud Build Service fetches the application artifact from Cloud Storage. That application artifact is then packaged into a Docker image by the Cloud Build Service and then pushed into either a container registry or artifact registry. And depending on the generation of function you're using, those functions will then point to this image in the registry at runtime. And there's another important point to note here. Because Cloud Function uses these services behind the scenes, there might be additional costs for having used these services as well. In terms of secrets management, we're using Secrets Manager to store the Slack token. And that token is then available to the Cloud Function as a mounted volume during runtime, which is at the bottom right here. In terms of identity and access management, both GitHub Actions and Cloud Functions have a service account associated with them. A service account is a special type of account in a Google Cloud project, which has a unique email address and is generally associated with a service or a resource rather than a user. So it's generally used by resources. And then those service accounts have custom IAM roles associated with them. And those custom IAM roles have least privileged permissions to interact with Google Cloud services. For instance, in this scenario, GitHub Actions can only do things like create a Cloud Function, create IAM roles for the function, and interact with Cloud Storage to fetch the application artifact. On the other hand, Cloud Functions can only do things like fetch the application secret from Secret Manager and interact with Cloud Storage to fetch the application artifact. And basically, these are the only things that these services are allowed to do in Google Cloud. We can also define conditions using common expression language, which gives us the ability to define a condition where the condition says that this resource is, these permissions effectively only apply to a single resource, and in this case, it's an artifact bucket, such that when GitHub Action assumes this role, it can only interact with this one bucket only. And you won't be able to interact with any other buckets in the project, which is considered best practice in terms of security. So this effectively allows us to implement permissions with least privileged access in mind. Now that we've seen how we can test the application locally, deploy the application to Google Cloud, once we deploy the application to Google Cloud, you get a HTTPS URL to invoke the function. Then you go ahead and set up Slack. And the way you do that is you first create a Slack app. You then navigate to event subscriptions. This is where you enter the HTTPS URL or the endpoint of the function. This is also where you tell Slack what events you want Slack to forward to your endpoint. For instance, in this scenario, we're asking Slack to forward the events when a Slack user joins the workspace or when a user posts a message in the Slack channel. The other thing that we need from Slack is the bot token, because if you think about it, the application uses this bot token to interact with Slack. And this is also where we define the scopes for the token. So what is the token allowed to do in your Slack workspace? And in this scenario, it can read reactions from a post, it can react to a post, and it can write a message to the Slack channel that the bot is invited to. And that is all we need to do in terms of setting up Slack. Now let's talk about continuous integration and continuous delivery using GitHub Actions. Traditionally, setting up a CI/CD pipeline between GitHub Actions and Google Cloud involved you creating a service account in your Google Cloud project. You then create a private key for that service account, and you then need to export that private key to GitHub as a secret. Then the GitHub Actions workflow would then use that private key to interact with Google Cloud services. And as you can see, this creates a secrets management problem, because every time we create that key, we need to duplicate that key into GitHub as a secret. There's also a risk of these secrets being leaked because of that reason. And finally, if there are organization level policies applied, like disable service account key creation, for example, you're then no longer allowed to create a service account private key, which then hinders developer productivity. Now let's look at how we can implement the same CI/CD architecture using short-lived OIDC tokens. We first create cloud roles, which trust GitHub's OIDC provider. Then every time the GitHub action workflow runs, GitHub's OIDC provider auto-generates an OIDC token, which is presented to the cloud provider. The cloud provider then validates that token and sends back a federated cloud access token, which is then used by the workflow to interact with Google Cloud services. As you can see, this provides a seamless authentication way between GitHub Actions and Google Cloud. Because of this, we no longer have to store secrets, long-lived secrets in GitHub. And finally, because we're allowed to implement custom IAM roles, we can only provide permissions to these services that they need in order to perform their job in Google Cloud, and only the permissions they need. This effectively allows us to implement permissions with least privilege access in mind. In terms of the GitHub Actions workflow for this application, the way this works is Terraform first authenticates to Google Cloud using Workload Identity Federation. Workload Identity Federation is an identity service in Google Cloud that lets you manage external identities. In this instance, it's GitHub Actions. Then Terraform uploads the application artifact to cloud storage. This is also where it stores the state information. It updates the state information as well. Then finally deploys the application to Cloud Functions. And as we know, this triggers a build process behind the scenes where Cloud Build generates a Docker image and uploads it to artifact registry or container registry. We'll now look into a quick demo on how the Slack bot works. This is a sample test Slack workspace that I'm using for testing. What I'll do is I'll invite a new Slack user. I've just got a test email that I got ready. What I'll do, hopefully we get a new invitation for the new Slack user. There you go. I'll quickly sign in as a new user. And now if I go back to Slack, what we'll see hopefully is that the bot has now welcomed me as the new Slack user. Amazing. I would also like to show you the other demo where, let's say I type in a Slack post where I talk about, for example, Kubernetes. So Kubernetes is the keyword here. And hopefully the bot then reacts to the Slack post with a Kubernetes emoji, which it did. Sometimes as users, we like to edit our post as well. What happens if we edit our post? And I add another keyword, for example, JavaScript. Hopefully it reacts with the JavaScript emoji, which it did. I'd also like to show you quickly the CI/CD side of things. So every time you push a commit to GitHub, it runs the CI tests. And for this application, it runs all the unit tests using Jest. And it gives you test coverage as well. So this is your CI bit. And to look at the continuous delivery bit, where it deploys the application to Google Cloud, every time you merge your changes to your mainline branch, whether it be master or main, it then goes off and it first sets up Terraform, authenticates to Google Cloud, sets up the Google SDK. But at the end, what we'll see is that it deploys the application to Google Cloud. So first initializes Terraform. And if you go down, you can see that it's effectively deployed the application to Google Cloud. And this is done not locally, but using our CI/CD process. And every time now we make a change, we merge our changes to master. We don't have to do anything because the application is automatically deployed to Google Cloud. moving back to the slides. Now that we've seen how we can test the application locally, how we can deploy it to Google Cloud to test it there, how we can set up CI/CD for the application, we now need to know how we can monitor the application in real time. And the way we do that is by using Google Cloud's inbuilt logging, monitoring, and tracing tools. Let's see how we can use those tools to monitor the health of our application. In terms of logging, you can use the Logs Explorer service, where you can construct a query where the resource type is Cloud Function, and that displays all the logs for your function. You can also view the same logs from Cloud Functions console. So you can either go to Logs Explorer and view these logs, or you can navigate to your Functions console, and you'll be able to see the same logs there as well. In terms of monitoring, where you need to monitor metrics for your function, like instance count, execution times, memory usage, you then need to navigate to Metrics Explorer, which will give you an overview with a chart and everything about the metrics for your function. And similar to logs, you can also view the same metrics from the Cloud Functions console. In terms of tracing, Cloud Trace is being used for tracing. This gives you a quick representation of how long things took inside the application. This is really useful, and it helps when you want to debug slowness in the application. So for example, if you don't know that something in your application is taking too long, for example, how do you debug that? You can use this tracing application to exactly pinpoint what inside the application is taking that long, which is useful and then helps you debug your applications. There's also an error reporting service in Google Cloud, whereby all the errors happening in the project flows through this error reporting service. We can also subscribe to notifications in the error reporting service, whereby Google Cloud will then forward those errors to the notification endpoint that we've selected. In this scenario, I've set up Slack notifications. And what I've done is I've generated a sample error from my application. And that error is then forwarded to Slack by Google Cloud when the error happened, which is a good way to be able to view errors right from Slack without having to logging in to Google Cloud to view the same error. And I'm sure like at work, everyone here must have got something like this, where you use Slack to investigate what's going on in your environment. I would like to talk about a few key takeaways now. Getting started with Google Cloud Functions, serverless functions in Google Cloud is really easy. In this example, we saw how we can use Terraform to deploy the application to Google Cloud and test it there. But in general, you can log into the console, and in your favorite programming language choice, whether it be Python or Node, you can create Cloud Functions right from the console, which is really easy. But it's important to think about all the best practices around having to build an application as such. For example, security, identity and access management, logging, monitoring, tracing, CI/CD, and others. It's okay and it's fine if you want to test things quickly from the console, but when you start thinking about productionizing your app, that's when you need to think about all the other best practices, security, identity, and everything else that you need to be able to monitor your application in real time in production. The other takeaway, Cloud Functions Generation 2 is basically Cloud Run service under the hood with all its performance. So Cloud Run is a fully managed container service in Google Cloud, which scales automatically. And in terms of performance, Cloud Functions Generation 1 can only handle up to 1 request per function instance at a time. On the other hand, Generation 2 can handle up to 1,000 requests per function instance at a time. Cloud Functions Generation 2 supports traffic splitting, so being able to create 2 versions of your application and being able to split percentage of traffic between them. This is really useful when you want to test a new feature, for example, with a subset of users, and then once you've tested that with the subset of users, you can release it to everyone else. So it's really good in terms of being able to do A/B testing. The other the other performance benefits of Generation 2 are it supports increased timeouts. It supports increased timeouts, and it also supports a lot more events than Cloud Functions Generation 1. Now you might ask, why not just use Cloud Functions Generation 2? If it's got all the performance benefits, why use Generation 1 for the Slack bot? And the reason is basically to keep things simple. For our use case in our Slack workspace, we only get a few messages per day, and there are only a few users joining per quarter. We don't really need all the performance benefits that Cloud Functions Generation 2 provides. So for our use case, keeping it simple, Cloud Functions Generation 1 fits the purpose. So that's why we're using Generation 1. Obviously, if there are a lot more events happening in Slack, and if we want to scale, we'll probably migrate to Generation 2. But for our use case currently, generation 1 is perfect. There are a few things to remember if you start using Google Cloud Functions Generation 2 though, which is in terms of logging. As you saw earlier, we constructed a query in Logs Explorer where we said that the resource type was Cloud Function. But as you know, Generation 2 uses Cloud Run service. So in order to view the logs for your Cloud Function, the query needs to say that the resource type is actually Cloud Run Revision, not Cloud Function. So it's a bit tricky there. And in terms of IAM permissions as well, because it uses other services like Cloud Build and Cloud Run, you need to apply permissions to these other services. For example, Cloud Build needs to build the Docker image and interact with Artifact Registry, so it needs permissions to do that. And Cloud Run, because as users, we need to be able to invoke Cloud Run, so you apply permissions to Cloud Run. And they're basically Cloud Run service under the hood. So even though you're using Cloud Function, if you go to your Cloud Run console, you'll see that that's where your application is actually running. So this was a bit of a learning curve for me to understand and try and figure out. So that's why I wanted to share this with you all. The other takeaway is that Slack expects a response within 3 seconds of the request. The demo earlier, I actually expected it to do a little bit, actually expected it to welcome the new Slack user twice, but it didn't. That's okay. But there's a concept of cold start in Cloud Functions, where before the Cloud Function can start executing a request, it needs to initialize its execution environment. And sometimes that takes up to a few seconds. And when that happens, when Cloud Function takes like 3 or 4 or 5 seconds to initialize its execution environment, and it hasn't replied to Slack with a response, what Slack will do then is it will retry the request. So it'll invoke the function twice with the same event. And what will happen is that the function will then process the same event twice, which is not ideal. So how can we get away with that? How can we solve this? One way to solve this would be to create an API gateway in front of the function, which will then immediately reply to Slack with a 200 OK, but then behind the scenes invoke the function asynchronously. So the Cloud Function can take its time to respond to Slack, but in terms of the contract between Slack and the function, basically API has responded to Slack immediately with the 200 OK, so Slack is happy, and we can take our own time to process the Slack event. So Slack also sends a response URL in the event, which we can then use to respond to the Slack event, and the timing is about a few hours. So you can use that URL to respond to Slack within your own time. So you don't have to respond to Slack immediately. So that was also a key takeaway that I wanted to share with you. And finally, you might ask, why build a Slack bot? Why you build a Slack bot in the first place? Why build something like this? Biggest reason for this is because it makes Slack community, it creates engagement in the Slack community, it drives engagement. Currently, it only does 2 things, welcomes new Slack users and reacts to Slack posts. But the possibilities are endless. You can make the bot do anything you want. For example, it can be productive in a sense that it can create Zoom meetings, it can create quizzes for us in the Slack workspace. We can even integrate ChatGPT to Slack with this bot, whereby users can use AI right from Slack. They don't even have to leave Slack, for example. I've also been able to learn programming languages by doing when building this application. So I built this application first in Python, then in Golang, and now in TypeScript. So by doing that, I've been able to learn different programming languages. Not just that, I've been able to learn cloud technologies by building an application like this. It might be a Slack bot. For me, it's a lot more. And my primary day-to-day job involves working in Amazon Web Services. But because I built this application in Google Cloud, I know a lot more about Google Cloud than I knew before I built this application. And not just that, as of last Monday, I'm also GCP Associate Cloud Engineer certified. So I was able to get a certification as part of building this application for fun. All right, so just wanted to share that point as well. Explorers, just want to quickly talk about the community. This is where the Slack bot also runs. Explorers is a Slack community of tech enthusiasts, like everyone here, who come together to learn and share and grow with each other. This is a community where, whether it be personal development, whether it be career development, everyone is here to bring the best out of you. We also like to help graduates and other people trying to find a job in the IT industry by reviewing resumes, conducting mock interviews, but mostly by listening to them, by being available to them, and spending a little bit of time to understand what they're doing right versus doing wrong, and being able to guide them to do the right thing. So a little bit of time from us, a little bit of knowledge and resource. But as us humans, we get the uttermost joy and satisfaction by being able to help other fellow human beings. And because we do that, and even though we've done that with a few people by spending a little bit of time and knowledge, this fills me with joy and satisfaction when I see that I've been able to help someone. So with that, I would really like to thank all my friends from Explorer Slack community who've come here to support me today and help me out throughout the journey to be able to present to you all today. I'd really like to thank all my mentors from Vicent and Stacks who've come here to support me today as well. I'd really like to thank all the organizers as well for giving me this opportunity to come here and present to you all today. But mainly Geshen for believing in me, for pushing me to be here today, to come in front of you all and present today, because public speaking has been one of those topics where I wasn't too confident about. I wasn't sure if I was going to be able to come here and present in front of you all. So what you've done, Geshen, is effectively given me an opportunity to expand my career by being able to come and present in front of you all today. So I really, really appreciate what you've done for me. Thank you. You can also scan the QR code if you want to add me on LinkedIn today. Yeah. Oh, it's not there.
Okay, so he has finished his presentation, but we would like to take some time to ask, get any questions if you guys have any questions to him.
Thank you. Thank you for the talk. Just one quick question. I've used AWS and Azure, not too familiar with Google Cloud Platform.
Yeah.
So, since you've experienced both of AWS and GCP,
yeah.
Which one in general has the bigger advantage or better, overall usability for your, anything?
That's a hard question. Thanks for the question. I think I've heard this question a few times today. For me, my experience, I found both Google Cloud and Amazon to be similar. For example, I use Lambda functions, which is similar to Google Cloud functions. You have IAM on Amazon, you have IAM in Google. So I found that they have different names for services, but they're kind of similar. In terms of performance, because I've run the same application in Amazon as well, I couldn't find a lot of difference in terms of performance. So obviously both Lambdas and Google Cloud functions have cold starts, which takes a little while to warm up before you can receive the request and process it. Things like so they're kind of similar in terms of, and you assign memory to the function, which is the same in Amazon and Google. So with the time I've been working with Google Cloud, which is a few months now, I haven't seen a lot of difference. And that might just be me because I haven't been playing around too much with Google Cloud. But as of now, with my experience, I feel I couldn't find a lot of difference. I know that Google specializes in GKE, Kubernetes and other things, which I haven't used, right? So a lot of AI coming up as well, all those things. So yeah, I guess I just need to do a little bit more hands around with Google in order to be able to clearly identify, which one's better, even if it is better, Yeah. So hopefully that answers your question. Yeah, cheers.
Anyone else?
Thank you for the talk. I know AWS have the reserve concurrency. In GCP, does it have similar things that you can scale into a degree similar to that kind of?
Like scaling?
Yeah, with reserve concurrency, how?
Oh yeah. It's the same. So in terms of cloud functions, you basically define the number of instances that are active at any given time, where you can say, oh, I want 5 active instances of my function ready at any given time. But obviously, there's cost involved of having those instances ready. So yeah, it's kind of similar to Amazon as well, where you can scale Lambda functions, where you can have reserved concurrency, I think it is, where you can say, oh, I want 5 concurrent Lambda functions waiting and ready to receive traffic at all times. But then, yeah, similar to Google Cloud, where you can define a number of instances that are ready to receive traffic at any given time. But obviously, there's cost associated when you do that. Because usually when you use serverless functions, it's generally idle, not doing anything until it receives a request, and you're only billed for the amount of time the function runs. So it could be 100 milliseconds, it could be 200 milliseconds, that you only billed for that duration. But then if you start using serverless functions for something like having standby instances running to receive traffic, that sort of defeats the purpose, I think, where you probably want to go down compute engine pathway or something. Because yeah, if you're using serverless, I guess you'd use it in a way you want to save costs, which is when you don't have any of those instances running at any given time. Does that answer your question, or did I go? But in general, yeah, it's similar scaling properties that you have in Amazon as well as Google Cloud Functions. Thank you. Cheers.
Oh, hi, a great talk. I just was curious about how much it costs to run your application, like per request.
Yeah, so it's free. So both in Amazon Web Services and Google Cloud, what I do is Amazon gives you a free tier of 12 months. So what I do is, because I use infrastructure as code, Terraform, CloudFormation on Amazon, I usually just set up my application in 2 minutes. I run a command, it deploys it to Amazon or Google Cloud, whatever. But I guess the point is, they both have free tiers. So Amazon has a year of free tier, but Google only has 3 months. So my Google account is actually nearly expired. So for my next talk, I'd probably need to move it to a different account. So yeah, usually what I do is I have, just move it, use a different account. That's what I do, to be honest. Like every year my Amazon account expires, I open a new account with a suffix in my email. Yep, new account. Do a make deploy, and that basically deploys the application to Amazon. I'm done. 2 minutes. It takes 2 minutes for me to do that. Yeah, yeah. And I basically run it for free. Is basically because our Slack group is, it's kind of like non-profit. We haven't registered as non-profit, but basically we don't have that. No one wants to spend that money to get a paid Slack workspace and do all of those things. So we try to create anything that's free. And especially Geshen knows a lot of tools that he uses a lot of tools, everything open source. He runs websites for free, things like that. So you might have a few questions for him later too.
Cool, yeah.
Thanks.
Anyone else? That's it? Okay. So yeah, thank you, Prasiddha. Let's give a big round of applause for him.
Thank you, everyone.
Okay, so our next speaker